I got rid of more numbers here. P equals 2L plus 2W. It's not enough just to say solve this, because then the question is, solve this for what? Yeah, I'm singing it too. So if I said solve for L, then L becomes the variable. Everything else becomes a constant. We treat it just like a number. To solve this for L, we would want to get the L by itself, which means we got to get the 2L by itself, which means we would need to subtract 2W to get rid of adding 2W. So that just gives us P minus 2W equals 2L. And then to get the L by itself, we would have to get rid of times 2. So we would divide both sides by 2, and we would get that L equals P minus 2W over 2. This is called a literal equation, where instead of using numbers, we're using a bunch of different letters, standing for different constants, treating only the thing we're solving for as the variable. If instead of solving for L, we had said solve for W, then W would be the variable. And we would want to get the plus 2W by itself. What's happening to that? 2L is being added. So subtract 2L. P minus 2L equals 2W. Divide both sides by 2. W equals P minus 2L over 2. So literal equations are just like regular equations. You use the same rules. So this was the formula for perimeter. We actually kind of used that earlier when we were talking about the fence. Here, by having it for W, you can plug in the perimeter and the length and get what the width should be. Or when it was solved for L, you can plug in the perimeter and the width and get what the length should be. Or in its regular form, when it's solved for P, you can plug in the length and the width and you'll find the perimeter. Literal equations, you can solve them for the variable you want to find first and then just plug things in, as opposed to plugging in what you have first and solving afterwards. So let's say we had D equals RT. This is a formula that's going to mean distance equals rate times time. If we solve it for R, then we would divide both sides by T. So we can get R equals D over T. But if we solve it for T, then we would divide both sides by R, and D over R would give us T. So when we're solving a literal equation, it will tell us what variable to solve for. And then we just do it. Use the same rules. Get rid of things by using opposites. Here's another formula. I equals PRT. Let's solve it for T. So we want to get the T by itself. Currently, T is being multiplied by PR. So we'll divide both sides by PR. I over PR equals T. So So let's expand this to some equations that have multiple variables that don't necessarily stand for a common formula that we're going to work with. So not an interest formula or a distance formula. Let's say we just had 3x plus 2y equals 6, and we wanted to solve this for y. Well, then we want to get the y by itself. We want to get the 2y by itself because the y is trapped in there. What's happening to the 2y right now? 3x is being added to it. Not because of this plus, but because of the fact that it's not negative. The fact that this is a positive 3x means that the 3x is being added. If it was negative, then the 3x would be subtracted. How do we get rid of adding 3x? We subtract 3x, and how do we keep it balanced? We do it to both sides. So 2y equals 6 minus 3x. Divide both sides by 2 to get the y by itself. And we have y equals 6 minus 3x over 2. Now, there are a couple different ways to write this same answer. When we see 6 minus 3x, remember, that's the same as 6 plus negative 3x. So we can add in any order. That's the same as negative 3x plus 6. So it's common practice that when we can, we write the x term first and then the constant term second. So 6 minus 3x, that's the same as minus 3x plus 6. Notice the 3x is negative, the 6 is positive. So that is a 6 being added to what? The negative 3x. Fraction rules. Look at that. This is true backwards, so this must be how we split it up. Common denominator, when we add on the top, keep the denominator. So this actually means we're dividing each of these by 2 separately. It is 2 separate terms because it is 2 terms on top. Three over 2, we can't do anything there. When there's an x on top of a fraction, we can push it off so it's kind of floating off on the side. And then 6 over 2 is 3. So these are 3 different ways to write that same answer. All of them are equally correct. It just depends on how far you take it. Let's do another one just like this. (4x plus 3y equals 12. We're going to solve this for y. To get the y by itself, we got to get the 3y by itself. To get rid of plus 4x, we would subtract 4x. So 3y equals 12 minus 4x. Divide both sides by 3. That means y equals 12 minus 4x over 3. And I could also write that as negative 4x plus 12 over 3, which I can also write as negative 4/3 x plus 4. So there's the 3 forms the answer could be. Where'd that 4 come from? Where'd the 3 go? Well, plus 12 divided by 3, because remember we split it. This would be negative 4x over 3 plus 12 over 3. That one doesn't reduce, but we can knock the x off. 12 over 3 does become positive 4. Okay, so that's a bit about literal equations. I will do one more in this group next time we run through this. I'll do some extra examples. A equals 1/2 h times the quantity big B plus little b. And let's solve for big B. Okay, well, the big B is currently trapped in this set of parentheses. We're going to go ahead and get that by itself. So we've got to get rid of multiplying by 1/2 h. Let's do it piece by piece so we don't overly confuse ourselves. Let's divide by the h first. So a over h equals 1/2 times, in parentheses, big B plus little b. And we can multiply by 2 over 1. Dividing by 1/2 is the same as multiplying by the reciprocal. Multiply these together, that's 2a over h equals big B plus little b. To get the big B by itself, we would have to subtract little b. Notice it doesn't get subtracted from the top, it gets subtracted from the whole thing. This is a piece. That piece, we would subtract b from both sides. Gets the big B by itself. So 2 big A over h minus little b. The second objective in this topic is using formulas to solve problems. So let's convert the temperature 5 degrees Celsius to Fahrenheit. Well, in order to do that, we need to understand that we're going to have some temperature in degrees Celsius. We're going to have some temperature in degrees Fahrenheit. We'll call the Celsius temperature C. We'll call the Fahrenheit temperature F. We need a formula in order to do this. And the formula is F equals 9/5 C plus 32. I highly recommend memorizing that formula. It is very useful. But since we're given the temperature 5 degrees Celsius, that means that C equals 5. Plug that into the formula. Once that's plugged into the formula, we simplify. 9/5 times 5. 9/5 times 5 is 9/5 times 5 over 1. The 5's cancel, leaving us with 9 over 1, or just 9. And then when we add the 32, we get that F equals 41. We can check that value. We do get it to check. It is correct. Thus, 5 degrees Celsius is equivalent to 41 degrees Fahrenheit. Hopefully at this point, if you have confusion in that example, the only confusion is where did the 9/5 and the 32 come from? Or where did the formula come from? We just need to know that formula. F equals 9/5 C plus 32. Our next example. A flower bed is in the shape of a triangle with one side twice the length of the shortest side, and the third side is 30 feet more than the length of the shortest side. Find the dimensions if the perimeter is 102 feet. So here we are encountering another example where we're given 3 sides or 3 things, and the second and third thing are given in terms of the first thing. In this case, the first thing is the shortest side. One side is twice the length of the shortest side, and another side is 30 feet more than the shortest side. So since the common, I don't want to say common denominator because we're not dealing with fractions, but since the common theme in all of these lengths is the shortest side, and we don't know what that is, that screams at us, hey, our unknown is going to be the shortest side. So let's call that X. And if X is the length of the shortest side, then the second side is twice the length of the shortest side. Twice X is 2 times X is 2X. And the third side is 30 feet more than the length of the shortest side. So the third side is 30 more than X, X plus 30. And we know for perimeter, we add the sides. So the perimeter of a triangle is A plus B plus C, where A, B, and C are the side lengths. So we take our formula, we substitute in what we know. We know that the perimeter is 102 because we were told the perimeter is 102 feet. Our sides were X, 2X, and X plus 30, so we add X plus 2X plus X plus 30. Now we go to solve. We combine like terms on the right. X plus 2X is 3X plus X is 4X plus 30. We want to get the 4X by itself. We need to get rid of plus 30. We do that with minus 30. We do that on both sides. 102 minus 30 is 72. 30 minus 30 is 0, so that goes away. We have 72 equals 4X. We want to get rid of multiplying by 4. We do that with dividing by 4. We do that to both sides. 4 over 4 cancels away, leaving us with X. 72 divided by 4 is 18. So our side lengths If the shortest side is 18, then the second side is twice 18, or 2 times 18, or 36 feet. And the third side was 30 feet more than the shortest side, so 18 plus 30 gives us 48 feet. We can check that when we add 18 plus 36 plus 48 together, that we do get 102. It is correct. So the three sides are 18, 36, and 48 feet. And that is the end of this topic. Number 1, 18 is greater than 2. We want to write the sentence as a mathematical statement. 18 is greater than 2. We don't want the greater than or equal to sign. We just want greater than. 18 is greater than 2. Number 2, use an integer to represent the value in the statement. 3,006 dollars in debt. In debt indicates that we would have a negative integer. So negative 3,006 would be the answer for number 2. Number 3, we want to tell which set or sets the number belongs to: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. In 3, we have the number 3. 3 is one of our counting numbers, so it is natural. All natural numbers are also whole numbers. All whole numbers are also integers. All integers are rational. And all rational numbers are real. So natural, whole, integer, rational, and real. That's our answer for 3. In 4, we have the square root of 19. 19 is not a perfect square like 16, 25, 64. So we can't simplify it down to a natural number. So it's not natural, it's not whole, it's not an integer, it's not rational. Square roots of numbers that are not perfect squares are irrational. And all irrational numbers are also real numbers. So irrational and real. Number 5, we have the number 0. 0 is not one of our counting numbers, so it is not natural. However, 0 is a whole number. All whole numbers are integers. All integers are rational. All rationals are real. So whole, integers, rational, real. That's our answer for number 5. Number 6. We want to take the absolute value of 18. Absolute value gives us the positive version of the number. So 18. In number 7, we have the absolute value of negative 7. Again, it gives us the positive version of the number. So our answer is 7. In 8, we want to take the absolute value of 0. Now, 0 doesn't have a positive version or a negative version, but absolute value, remember, means distance from 0, and 0 is 0 away from 0. So it does exist. It is 0. Number 9, we want to write the fraction in lowest terms. We have 35 over 42. Now we can get there right away by noticing that both of these numbers are divisible by 7. Divide by 7 on the top, divide by 7 on the bottom. That gives us our answer of 5/6. But that's not the only way to get this. And remember, we can write it as 7 times 5, 7 times 6, cancel the 7s. Really, it's doing it the same way. We're dividing by 7, we're canceling a factor of 7. Or you could have gone with prime factorizations. 35 is 5 times 7. Both of those are prime. 42 is 6 times 7. 7 is prime. 6 is 2 times 3. Those are prime. So we could rewrite as 5 times 7 over 2 times 3 times 7. The 7s cancel. We're left with a 5 on top, and then 2 times 3 on the bottom, which is 6. So 3 different ways of showing that we get 5/6 as an answer for number 9. Even though you might have been able to get away with doing number 9 without knowing how to do a prime factorization, 10, you're forced to do a prime factorization of the number 60. Write the number as a product of primes. So you can go that 60 is 6 times 10. 6 is 2 times 3. Both of those are prime. 10 is 2 times 5. Both of those are prime. We end up with 2 times 2 times 3 times 5. Of course, that's not the only way to break this down. Maybe instead of 6 and 10, you did 2 and 30. 2 is prime. 30 is 5 times 6. 5 is prime. 6 is 2 times 3. No matter how you break it down, you're going to get 2 times 2 times 3 times 5. I'll show it one more way. Maybe you did 20 times 3. 3 is prime. 20, you can go 4 times 5. You can go 10 times 2. It doesn't matter. I'm going to go 4 times 5. 5 is prime. 4 is 2 times 2. The 2's are prime. 2 times 2 times 3 times 5. No matter how you break it down, you're going to end up there. Number 11. One-eighth times 5/9. Nothing cancels on the top and on the bottom, so we have to multiply straight across the top, multiply straight across the bottom. We get 5/72. Number 12, 2/9 times 5/6. This time we do have something that cancels on the top and on the bottom. 2 and 6 are both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Nothing else cancels. We have 1 times 5 over 9 times 3, which is 5/27. If you didn't notice the canceling, and you went straight across the top and straight across the bottom, you can still get to the answer. 2 times 5 is 10. 9 times 6 is 54. You would have to reduce. Top and bottom can both be divided by 2. 10 is 2 times 5. 54 is 2 times 27. The 2's cancel. We get the 5/27. So you either have to cancel in the original problem or cancel at the end. Either way, you're going to get to 5/27. Number 13. 3/8 divided by 10/3. You absolutely cannot cancel the 3's. Canceling is something we could only do with multiplication. This is division. Step 1 of a division problem is to turn it into a multiplication problem. Keep the first, change division to multiplication, flip the second, take the reciprocal of the second. We can see here nothing cancels. Nothing on the top shares a factor with anything on the bottom. So we multiply across the top 3 times 3. We multiply across the bottom 8 times 10. This gives us 9/80. (14), we have mixed number multiplication. 5 1/3 times 3 3/4. Now we can't just multiply the numbers and multiply the fractions. Remember that when we're multiplying mixed numbers, we have to change them into improper fractions first. 3 times 5 is 15 plus 1 makes 16/3 times 4 times 3 is 12 plus 3 makes 15/4. You're going to have one heck of a time multiplying straight across the top, straight across the bottom, and then simplifying. These are big numbers. But we can cancel. We can make these numbers smaller while keeping the problem exactly the same. 16 and 4 are both divisible by 4. 16 divided by 4 is 4. 4 divided by 4 is 1. 3 and 15 are both divisible by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. That means this is 4 times 5 over 1 times 1, which is 20 over 1, which is just 20. Number 15. We have 7/9 plus 1/9. We like this problem because we can only add or subtract fractions that have the same number on the bottom, just like this. Since both of these have a denominator of 9, a 9 on the bottom, our answer will have a 9 on the bottom. And then we add across the top. 7 plus 1 is 8. So 8/9. Number 16. Again, we like this one. 7/12 minus 1/12. We have the same number on the bottom and we keep that. Sorry about that. Keep the number on the bottom. 7 minus 1 is 6. 6/12 is one of the answers, but we have to write our answer in lowest terms. 6/12 would be wrong. It reduces to 1/2. Top and bottom both divide by 6. Number 17. We don't like this. 2/7 plus 5/6. We can't add these until we have the same number on the bottom. For 7 and 6, that number on the bottom would have to be 42. 42 is the least common multiple of 7 and 6. Seven times 6 is 42. 2 times 6 is 12. 6 times 7 is 42. 5 times 7 is 35. Keep the 42 on the bottom. Add across the top. 12 plus 35 is 47. 47 over 42. We don't have to change that to a mixed number. We can see that because there are no mixed number answers, because there wasn't a mixed number given in the problem. Number 18. (17/4) minus 2. Well, keep in mind that 2 is 2 over 1. we would need the same number on the bottom of both. That's going to be 4, least common multiple of 4 and 1, which means the 17/4 doesn't change. 1 times 4 is 4. 2 times 4 is 8. And then 17 minus 8 gives us 9/4. Number 19, the circle represents a whole, or 1. Use subtraction to determine the unknown part of the circle. 1, the whole circle, minus 1/13 minus 3/13. 1 can be expressed as 13/13. So we're subtracting 3 fractions. 13 on the bottom of all of them, so 13 on the bottom. And then subtracting across the top, 13 minus 1 is 12. 12 minus 3 is 9. 9/13. So I warned you in advance that nearly 2/3 of the test would be from class 1 and class 2 material, because fractions are important. We're finally moving beyond that for our last 11 problems. Number 20. 8 squared minus 4 times 6, order of operations. PEMDAS, parentheses, exponents. Multiplication and division left to right as we come to it. Addition and subtraction left to right as we come to it. No parentheses or grouping symbols here. So first, let's take care of the exponent. 8 squared is 8 times 8. That's 64. Next order of operations would have us do the multiplication before the subtraction. 4 times 6 is 24. Finally, 64 minus 24 is 40. Number 21, we have negative 22 plus negative 23. When we add two numbers with the same sign, we give that common sign to our answer. So since we're adding two negatives, our answer is negative. Then we add the absolute values. 22 plus 23 is 45. So negative 45 would be the answer. Fractions are important. They don't go away just because we're not in the fraction section anymore. In number 22, we are subtracting negative 4/5 minus negative 7/10. Minus a negative gets rewritten as plus. Negative 4/5 plus 7/10. We need to know which one's bigger, 4/5 or 7/10. So we need a common denominator so we can compare them. We would need that common denominator to add these together anyway. That first fraction is negative. The shared number on the bottom is going to have to be 10, which means 7/10 doesn't change. 5 times 2 is 10. So we go 4 times 2 is 8. Since 8/10 is bigger than 7/10 and 8/10 comes from the negative number, our answer is going to be negative. And then 8 minus 7 is 1. 8/10 minus 7/10 is 1/10. So our answer, negative 1/10. Number 23, the absolute value of negative 5 minus 5 squared minus in parentheses negative 3 minus 3. First, take care of the grouping symbol. The absolute value of negative 5 is positive 5. We have another grouping symbol. In here, we have negative 3 minus 3, or negative 3 plus negative 3. That's negative 6. Exponents next. 5 squared is 25. And then we have this minus a negative. We can change minus and negative to plus. Finally, addition and subtraction from left to right as we come to it. So first we would do the subtraction, because that comes first from left to right. 5 minus 25 would be negative 20. Negative 20 plus 6 would be negative 14. Number 24. Fractions are important. Negative 3/14 right up against in parentheses negative 3/20. A number right up against parentheses means multiplication. So nothing cancels in the fractions. We'll go straight across the top, straight across the bottom. And since this is negative times negative, our answer is positive. 3 times 3 is 9. 14 times 20. Well, 14 times 2 would be 28, so 280. 9 280ths. Number 25. Negative 7 in parentheses squared. We're squaring the entire negative 7. That's negative 7 times negative 7. Negative times negative is positive. So our answer is positive 49. Number 26. 52 over negative 2. That's division. It's positive divided by negative. The signs are different, which means our answer is negative. 52 divided by 2 is 26. So our answer is negative 26. $27. We're given x equals negative 4. We're given y equals negative 2. And we want to evaluate 5x plus 2y. So we're plugging in negative 4 for x. We're plugging in negative 2 for y. The multiplications happen before the addition. 5 times negative 4 is negative 20. Plus 2 times negative 2 is negative 4. Negative 20 plus negative 4 gives us negative 24. Finally, our last three have to do with our properties of real numbers. In 28, we want to use a commutative property to complete the statement. Commutative property is the one where we move the things around. 3 plus x is the same as x plus 3 by the commutative property of addition. $29. We're given 6y plus, in parentheses, 5x plus 2. We want to use an associative property to complete this statement. The associative property, associate, group. This is the one where we change the grouping. So instead of the parentheses being around 5x plus 2, we put them around 6y plus 5x. Finally, in number 30, we want to use the distributive property to write the expression without parentheses. And then simplify if necessary. The distributive property says we multiply the negative 6 by the x, and we multiply the negative 6 times the positive y. Negative 6 times positive x is negative 6x. Negative 6 times positive y is negative 6y. Identify the numerical coefficient of the term. We're given negative 9x. Since the coefficient is the number in front of the variable, including the sign, the coefficient is negative 9. Number 2, simplify the expression by combining any like terms. We're given 2b minus 6b. Remember, we can think of variables as things when we're combining them, and 2 of them minus 6 of them would be negative 4 of them. So 2b minus 6b is negative 4b. Number 3, simplify the expression by combining any like terms. We're given 5.7w minus 1.9 minus 3.6w plus 4 plus 2.9w. So here is the problem. We can rearrange so that our w terms are all next to each other. Make sure that the negative in front of the 3.6w stays in front of the 3.6w. Make sure that the plus in front of the 2.9w stays in front of the 2.9w. Make sure the negative stays in front of the 1.9. Make sure the plus stays in front of the 4. The signs in front travel with our terms. Once we rearrange, we can go ahead and start simplifying. 5.7 of them minus 3.6 of them, these w's, would give us 2.1 w's. Carry the rest down. The 2.1 w's plus the 2.9 w's give us 5 w's. So the w terms all combine to give us positive 5w. We carry down the rest. We still have to take care of the negative 1.9 plus 4. And negative 1.9 plus 4 is positive 2.1. That would be the same as positive 4 minus 1.9. So putting that all together, we get an answer of 5w plus 2.1. Number 4. We want to solve x minus 8 equals 2. We want to get the x by itself, so we're going to add 8 to both sides. That cancels out the negative 8 on the left, leaving us with just x. On the right, 2 plus 8 gives us 10. So x equals positive 10. Number 5, we want to solve 9x equals negative 63. Again, we want to get the x by itself on the left. We undo multiplying by 9 with dividing by 9. Whatever we do on one side, we have to do to the other. So we divide both sides by 9. That leaves us with just x on the left. And negative 63 divided by positive 9 would be negative 7. Negative divided by positive is negative. So x equals negative 7. Number 6, a little more complicated here. We have negative 5/13 k equals negative 10/13. To get rid of a fraction, we multiply by the reciprocal. So to get rid of the negative 5/13, we're going to multiply by negative 13/5. Flip the fraction, keep it negative. Whatever we do on one side, we do on the other, so we're multiplying both sides by negative 13/5. On the left, that just leaves us with k. On the right, we want to calculate negative 10/13 times negative 13/5. Negative times negative is positive, and the 13 on the bottom cancels with the 13 on the top, leaving us with 10/5. It's positive again because we have negative times negative. Those cancel each other out and become positive. The 13s went away, leaving us with a 10 on top and a 5 on the bottom. Finally, 10 divided by 5 is 2. So k equals positive 2. Number 7. We want to solve 3r plus 2 equals 17. We want to go ahead and start by trying to get the r by itself, which means we need to get the 3r by itself, which means we need to undo adding 2 with subtracting 2. Whatever we do on one side, we do on the other. So we're subtracting 2 from both sides. That leaves us with just the 3r on the left, and 17 minus 2 gives us 15 on the right. We want to get that r by itself. We want to undo multiplying by 3. We do that with dividing by 3 on both sides. 3r divided by 3 just leaves us with the r on the left. 15 divided by 3 leaves us with positive 5 on the right. So r equals positive 5. Number 8. We want to solve negative 8 equals negative 3x minus 5. We want to start trying to get that x by itself, which means we need to get that negative 3x by itself, which means we need to undo minus 5. We undo minus 5 with plus 5. Whatever we do on one side, we do on the other. So we're adding 5 to both sides. On the right, the minus 5 plus 5 cancel away, leaving us with just the negative 3x. On the left, negative 8 plus 5 is negative 3. So we have negative 3 equals negative 3x. We want to get that x by itself. We need to undo multiplying by negative 3. So we divide both sides by negative 3. Negative 3x divided by negative 3 just leaves us with our positive x on the right. Negative 3 divided by negative 3 leaves us with positive 1 on the left. So our answer is x equals 1. Number 9. We want to solve the equation 3 times the quantity 2z minus 2 equals 5 times the quantity z plus 2. We always start when there's parentheses by removing the parentheses, and we have to use the distributive property to do that. So on the left, we multiply the 3 times both terms, and we get 6z minus 6. 3 times 2z is 6z. 3 times negative 2 is negative 6. On the right, we distribute the 5 to both terms, and we get 5z plus 10. 5 times z is 5z. 5 times 2 is positive 10. So now we have 6z minus 6 equals 5z plus 10. Let's go ahead and get our z's all on one side. We can subtract 5z from both sides to accomplish this. On the right, 5z minus 5z cancel each other away, leaving us with just 10 on the right. On the left, 6z minus 5z is 1z. So we just have z minus 6. Last time I saw a 1z, it looked different than that. It was on a baby. Okay, enough jokes. Z minus 6 equals 10 is what we have right now. We want to get rid of minus 6 to get that z by itself. We add 6 to both sides. The minus 6 plus 6 cancel away, leaving us with just z on the left. And then 10 plus 6 on the right gives us 16. So positive 16 is our value for z when we solve in number 9. Number 10. We want to solve this equation that has fractions in it. 11/4 x plus 3 halves equals 5 halves x. We can always simplify the problem by multiplying both sides by the LCD to clear the fractions. In this case, our denominators are 4, 2, and 2. The least common multiple of 2 and 4 would be 4. So the LCD is 4. Let's multiply both sides of this equation by 4 to clear the fractions. Be careful when you multiply the left by 4. That's 2 terms, so each term needs to be multiplied by 4. And of course, we multiply by 4 on the right as well. This would give us 44/4, which cancels to 11. This would give us 12 halves, which cancels to 6. And this would give us 20 halves, which cancels to 10. So we have 11x plus 6 equals 10x, a much more manageable problem to solve than working with all these fractions. Since we don't want to move too much around, because the more we move, the more potential for error there is, let's just go ahead and subtract the 11x from both sides, moving all of the x's to the right. 11x minus 11x cancel away, leaving us with just positive 6 on the left. Be careful, on the right, 10x minus 11x would be negative 1x, just negative x. So now we have 6 equals the opposite of x, but we want x. So let's take the opposite of both sides. Negative 6 equals x. Number 11. Again, we have a complicated looking equation to solve. This time it has a bunch of decimals in it. 0.07 times the quantity 4x minus 1 equals 0.28 times the quantity x plus 7 minus 2.03. Let's get rid of the decimals. In each term, and we have 1, 2, 3 terms, we will move the decimal point 2 spaces to the right. 1, 2. 1, 2. 1, 2. Now all the decimals are gone. We have 7 times the quantity 4x minus 1 equals 28 times the quantity x plus 7 minus 203. Distribute to clear those parentheses on the left and on the right. On the left, 7 times 4x is 28x. 7 times negative 1 is minus 7. On the right, 28 times x is 28x. 28 times positive 7 is positive 196. I used a calculator to get that. Bring down the minus 203. Simplify on the right. Positive 196 minus 203 is negative 7. And look what happens. The equation we have now is the same on the left as it is on the right. 28x minus 7 equals 28x minus 7. When that happens, when we get the exact same thing on the left and on the right, that is an identity. And our answer is all real numbers. Doesn't matter what we plug in for x, it will always be true. All real numbers. Number 12. We have a word problem that we have to translate and then solve. 4 times the difference of a number and 1 is equal to 6 times the sum of the number and 3. Find the number. So when we translate, we have 4 times the difference, subtraction inside parentheses, the difference of a number and 1. So x and 1 fill out the 2 spots inside the parenthesis on either side of the subtraction sign. Is equal to, that's our equal sign, 6 times the sum. So 6 times in parentheses a plus, the sum of what? The number and 3. So x and 3 take up both sides of the addition sign inside the parentheses. Now we do what we've been doing. We want to get rid of the parentheses, so we distribute. On the left, 4 times x is 4x. 4 times negative 1 is negative 4. Equals on the right, 6 times x is 6x. 6 times positive 3 is positive 18. So we have 4x minus 4 equals 6x plus 18. Let's go ahead and get our x's on one side. I'm moving them from the left to the right. You can go the other way. You'll get the same answer. Your steps will just start looking different. I subtract 4x from both sides. 4x minus 4x cancel each other out on the left, leaving us with just this negative 4. On the right, 6x minus 4x is 2x. 6 of them minus 4 of them is 2 of them. Don't forget we have this plus 18 as well. And we'll never add 2 plus 18 because the 2x has an x, the 18 does not have an x, and they both have to have x's, or both have to not have x's for us to be able to combine them. So we're at negative 4 equals 2x plus 18. Let's go ahead and subtract 18 from both sides, starting towards getting that x by itself, which means we need to get that 2x by itself. Subtract 18 from both sides. On the right, plus 18 minus 18 cancel each other out, leaving us just with the 2x. On the right, negative 4 minus 18 would give us negative 22. So we have negative 22 equals 2x. To get that x by itself, we need to undo multiplying by 2. We do that with dividing both sides by 2. 2x divided by 2 leaves us just with our x on the right. Negative 22 divided by positive 2 gives us negative 11. Negative divided by positive is negative. So our answer for x, once we solved the number that we're looking to find, is negative 11. Number 13. A 12-foot board is cut into 2 pieces so that one piece is 8 feet longer than 3 times the shorter piece. If the shorter piece is x feet long, find the lengths of both pieces. So when we think about how to set this up, we know that the total board equals the shorter piece plus the longer piece. And even if they didn't tell us that the shorter piece is x feet long, we would let x equal the shorter piece because the piece lengths are given in terms of the shorter piece. One piece is 8 feet longer than 3 times the shorter piece. We don't have any other information about the shorter piece. The shorter piece becomes our variable x. 8 feet longer than 3 times the shorter piece would be 3x plus 8. So that's the longer piece. So when we replace our values, the total board is 12. The shorter piece is x, and we're adding to that the longer piece, 3x plus 8. So we have 12 equals x plus 3x plus 8. Combine like terms, x plus 3x gives us 4x. So we have 12 equals 4x plus 8. We want to get that x by itself, which means we need to get that 4x by itself. We need to get rid of adding 8. We do that with subtracting 8. Whatever we do on one side, we do on the other. So we are subtracting 8 from both sides. On the right, 4x plus 8 minus 8. The plus 8 minus 8 cancel each other away, leaving us with just the 4x. 12 minus 8 equals 4. So we have 4 equals 4x. Finally, divide both sides by 4, giving us x equals positive 1. That means the shorter piece is 1 foot. And by process of elimination, that only leaves you one answer. But how do we find that the longer piece is actually 11 feet? The longer piece is 3x plus 8. X is 1, so we plug that in. 3 times 1 plus 8. That would be 3 plus 8, which is the 11 feet that we're expecting. So the shorter piece is 1 foot, the longer piece is 11 feet. Number 14. Substitute the given values into the formula and solve for the unknown variable. We're given P equals 2L plus 2W. That's the formula for the perimeter of a rectangle. We don't need to know that that's the formula for the perimeter of a rectangle. It just is. It's a fun fact. Substitute the given values. They give us that P is 20. They give us that W is 8. That means that the unknown variable we're solving for is L. 2 times 8 is 16, so we simplify. 20 equals 2L plus 16. And we're old hats at solving by this point. We want to get the L by itself, which means we need to get the 2L by itself, which means we need to get rid of plus 16, and we do that with minus 16. Subtract 16 from both sides. The plus 16 minus 16 cancel each other away on the right, leaving us just with 2L. On the left, 20 minus 16 gives us positive 4. We have 4 equals 2L. Divide both sides by 2 to get that L by itself, and we get that L equals positive 2. 4 divided by 2 gives us 2.